why I don't leave that screen up for you guys to see. All right, 221. Let's check answers. As I announced, if you want to check your answers, wait to turn it in until after. So generic rectangle multiplication, right? Now, I will tell you, we did not get taught this when I was in school, but now that this is how we teach multiplication, my life has changed. Like, literally. So, now, you won't always think about the rectangle. Eventually, like as you get up into the higher math, and this is one of the advantages of me teaching the math that you're heading towards, not freeze. The way you're going to end up kind of looking at this, is we do distributive properties. So what you're doing right now with the generic rectangle will eventually say, okay, 50 times 30, 50 times 2. And when we do that, we do 5 times 3 is 15. And then we put 2 zeros on it because both of them would have a 0. Like 50 and 30. So that's your top left of your box. And then I do 50 times 2, which is 100. That's the bottom left number. Oh, yeah. Nobody shut the wall, did they?
Hi, Raleigh. And another girl just underneath.
You don't want to hear math. By the way, prize for anyone who can find my missing pen. One of these has gone rogue. I bet it's somewhere in the classroom. Probably magnetized. Huh? There are 2 under my desk. Those are not what I'm talking about. Those are the stairs. Not really, but it scares me to check them out. Well, sounds like it's back
No, I
there.
got it. Which way over there? Right there.
All right. So all of that to also say these, if you come up to do stuff, now live over here because it magnetizes better. So this bar right here is probably.
Do we all get a prize?
Maybe. If everybody turns in their homework today, then we can talk. The afternoon class had that happen on the first homework submission.
Oh, yeah.
Sorry, not the 5. Crap.
Mr. Hudson.
You're all asking me questions and I can't think. Hold on.
Oh, no, you told me to tell you something.
What?
Like a question, and then it was like messed up, like D for 239. You said like don't do it because like it's messed up.
Oh yeah, sweet. We will talk about that. So then you do 40 times 30 and 40 times 2, and that's the right side of your generic rectangle. Any questions on generic rectangle multiplication? There was a little math notes box in your homework.
So when I'm doing multiplication, I'm just gonna look at a piece of paper and draw a rectangle.
You can, yeah, if you don't have a calculator. Unless you're a human calculator, you can do 54 times 32 in your head. But I can't, so.
So like in the middle of the grocery store, you're just gonna look at a piece of paper?
No, in the middle of the grocery store, after you learn this process, you'll be like 50 times. And you'll be able to approximate it really closely.
But I haven't done it. Need it.
All right, moving on. So then we have 7,098. Most of the time, yeah, we understand you have a calculator, but it's the thought process of how do we get to these final numbers and being able to approximate them. 37, you have like multiple options, so just check your work. Sorry, then 38, 15 feet, 16, 8, 11. What? Wait, I heard a wait. Somebody said wait. So, part D of 39 is a really tough question. So if we go and look at this one. I had a bunch of people coming to ask me about this question. Finally, I just got to the point of saying, let's all talk about it tomorrow together. Because even if you got the answer from your calculator, I have a preference of one thing is better than the other. When we're doing this skill of figuring out how big one of these is, what math do we do? Who can help me through this? Yeah, really?
You take the number that you like the total or
Distance.
The distance.
And then you divide
Yeah, we take the distance and divide by the amount of gaps, or the amount of jumps, or the amount of steps, or whatever you say in your head. And that, when we type it into the calculator here, comes out to be 3.3 repeating forever. Which you could write, that's 3.3 repeating forever, which would mean that would be 6.6 repeating forever. But this would not be 9.9 repeating forever. Well, unless that equals 10, and we can argue that all day long. Or, the more accurate way to do this, that 10 divided by 3 is also a number I could just put right here. Right? Improper fractions are our friends. And if that's 10 thirds, what is here? 20 thirds. And what's here? 30 thirds. Is 30 thirds exactly equal to 10? Yeah. Is 9.9 repeating forever exactly equal for 10? We're not sure. We have not pursued that argument far enough to be able to make a final conclusion. But that is a question we'll continue to talk about. Is 9.9 repeating forever, or is 0.9 repeating forever actually equal to 1? Right? Like, it's right here. Sorry, Nick reminded me that I wanted to talk about 39 and I got excited. Yes, because I cleaned up my desk yesterday. Sometimes you just gotta clean things out. It's really clean now. And then 40. Sorry, so the other ones were easier. ABC here. I think most of us did that division pretty easily. It was just D that people struggled with. And then 40, 41. Remember that mean is average. Right? It is the average of the values. Add them all up, divide by how many you have. If you have 211, 212, and 221 ready to turn in, you can do that right now if you want. Let's give you like 90 seconds. If you want to turn those in, all of you must have grabbed your homework back. Proud of you. All right, turn that in now if you want, or at some point before tomorrow, right? Not due today because you get the 2-day rule, but turn that in by tomorrow, please. You can turn them in now if you want. Yeah, these first three, 211, 212, 221. I don't even need to go back there. I need to go back to my smart board. Everyone good here? So these are due by tomorrow. Please make sure your name is on them and that they're in some kind of order, either newest to oldest or oldest to newest. You're going to need today's blue sheet out, so please keep that out. 222. Makes me want to dance.
What?
22. If you wear a 22.
No. You don't.
No? I don't. How do you know?
Because that would be weird.
We're all weird, man. You're not weird, you're boring. What?
I'm not weird. Yes, you are. You're the one that.
No, you're weird as kid.
You
You
walk
are.
around like.
Oh, yeah? What was that again?
Well, I don't know. No, I'm talking about good.
I know. All right. So today we move on. We're all weird. It's okay. Be proud of it. Let your weird flag fly.
Yes.
So today we are talking more about adding integers and rational numbers. So before we dive into this, it's like, okay, so we're adding integers and rational numbers, but what is an integer and what's a rational number? Right? This is when the teacher's like, we're doing this thing, and you're like, okay, sure. So let's make sure that we understand what we're talking about here. On your paper, the first thing on it, put your eyes on it, tells you what integers are. Right? So read that real quick. And that's your math notes box, like after the lesson. But the one thing that I think can easily describe it, that they say like steps or no steps in either direction from 0, like whole steps. Integers are entire numbers. That's how my brain remembers it. So integer, I don't know why my computer does that, but at least we know how to solve it. If I was you, below or around somewhere close to the word integer, I would just write the word entire. Sorry about my E. That is a carryover from when they made us write cursor. Now, rational numbers, you don't even have to write anything. You could just underline or highlight ratio. Is at the root of that word. Now, I couldn't fit the rational numbers, like definition notes box, on your paper, so you might draw a little square off to the side. Rational numbers, or you can put it on your graph paper, because you should have graph paper out, you should have the regular out. Just means that it's any number we can put into a ratio. So to talk about rationals real quick, and yeah, if you have graph paper, this would be great to go in there. Adding integers and rationals was today's title, but we didn't know what integers and rationals meant, so that's why we're trying to take a moment to talk about that. Rational numbers, not hashtags. That symbol belonged to the word number before it ever belonged to the word hashtag. Rational numbers are numbers like 3, right? Because 3 can be written as a ratio, as a fraction, 3 over 1. Rational numbers are also numbers like 0.5. Now, 0.5 is not an integer because it's not an entire value. Yeah, so integers, now Nick made the statement that I'm like, well, yeah, kind of. Nick just said the whole numbers, right? Yeah, but what's the difference between the whole numbers and integers? What do whole numbers not include that integers do? Ooh, I can't quite. So both your hands are halfway up. Really? You're right. Whole number doesn't include 0, but there's more. Whole numbers, Morgan. Yeah, the negatives. Whole numbers are whole pizzas. Okay, and I am a pizza fan. So can I order 7 whole pizzas? Yes.
Yeah.
Can I order 8,524 whole pizzas? That would be
You
awesome.
could, but
It's going to take a while for them to make them.
Might
Also,
need
that's
like
gonna be a lot of
like a month's notice.
Well, do you know how many pizza places are around? We just call every single one. But can I order 3.5 pizzas? No, they won't. They'll say, so you want 4, and then they'll make you pay for 4. Can I order 0 pizzas? What? Wait. Yeah, I can. So 0 actually does stay with the whole numbers, although it doesn't seem like it should.
Hey, you order
Right.
your president.
I'm ordering 0 pizzas right now.
You can learn just
Did you see how good I did that? Order 0 pizzas. Can you order -2 pizzas? No.
No, because that means you owe them.
You call Domino's, you say, hey, I want -2 pizzas. They're like, great, can we get sausage and pepperoni on the first one? And like, you'd owe them pizzas. That doesn't make sense. It can't happen. But rational numbers include the positive and the negative. They include the whole values and the partial values. So numbers like 0.5, it can become a ratio, right? It can become 1/2. And here's the surprising thing. Repeating numbers, repeating decimals, those are also rational numbers. Why? Why is 0.1 repeating a rational number? Bella? Not because it can be rounded. We do not want to round. We got to keep it accurate. We got to keep it precise. Will?
Because it's not a whole, it's like you can put it over something.
So rational numbers, if we want to formalize this, can be written, I promise I will make this a short definition, but you should write this down, can be written as a, I'm going to do this in capital letters, but you can make that choice, as a ratio, which is another word for fraction. We, the other day, talked about what fraction turns into 0.1 repeating. What was that rule for? Yeah, it's over a 9, right? So this is 1/9. That is a rational number, right? 1 over 9, it's a ratio. So repeating decimals also count as rational numbers. Now, here's the trick, though. You can't really add the decimal form. It's really tough to work with repeating decimals because it never stops. But we can work with fractions. This is where fractions are better. I'm not saying always, but this is where fraction form is better. we have any questions on what makes a rational number? Roger that. So, some of these are integers, some of these are rationals. On your paper, on your blue sheet, this is all on your blue sheet. I give you space for this. We're going to solve all these through F. So we'll do A real quick together. And of course you can use a calculator. We're trying to avoid that because sometimes it's quicker to not use a calculator. So when we have positives and negatives, what I think of in my mind is good guys and bad guys. If you've ever seen West Side Story or any of those, really probably most movies, or I guess if you've seen the Avengers or whatever, like good guys always like team up on one side and the bad guys always team up on the other side normally because you don't intermix until you fight, right? Like everyone kind of like is off on their, let's put the good guys with the good guys and the bad guys with the bad guys. So 8 and 2 are going to work together. Just go ahead and add those first and get, well, we're really working with 10 and a negative 3, which we know is 7.
So negative numbers are just like subtractions, right? Unless you're using a negative.
It's the same thought. It can be subtraction or it can be negative, but like minus a negative is different. That's take away bad guys.
So then can I just like write minus 3 or I have to write
Oh, you can
plus?
write minus 3.
Okay.
It's the same, but I did plus the negative because it started in parentheses.
This is a weird question, but why is there a giant trophy on here?
Oh, it's a Final Fantasy.
Yeah, I'm
fantasy
doing
book.
that for one of our custodians here. I'm putting the placards on them because it's kind of mathy, how you like have to space them. So he asked me to do it.
Did you like make that, or is that something
No,
you
he
got?
got it ordered and sent to him. I'm just putting the plaques on it. Yeah, I'm doing a favor for a friend. So in B, if we group the good guys together, what's 12 plus 7?
That would be 19.
19. Now don't write it yet, because then check, are your decimals going to carry anything up?
No.
What's 0.25 plus 0.5?
75.
Yeah, 75, right? 75 hundredths. So this becomes 19 and 75 hundredths. Now why is that convenient with the number that I have? It's 75 hundredths, right? So we can first think about, well, the positive 75 hundredths and the negative 75 hundredths will cancel out. And then I just have to do 19 minus 1. 18, right? Go ahead and try to do C, D, E, and F on your own. My advice is if there's more than 2 terms, put good guys with good guys, bad guys with bad guys, and then put them all together. I'm going to give you a few minutes. Yeah. So I put the 12.25 with the 7.5. First thing we thought about was what's 12 plus 7. So that's 19. Then 0.25 plus 0.5 is 0.75. There's another way I can look at 0.5 if I want to give it 2 decimal places. Is 50 hundredths. Right, so I have 25 hundredths and 50 hundredths. Does that make sense now? So I would put that 0 in there if that was like a little weird for you. And then down here, that is 2 decimal places. That is 3 decimal places, and then that is 1. Hey, Araya pointed out something really, really good that I breezed over. When we have different amounts of decimal places, you can always add zeros to make the same amount of decimal places. You can always add zeros. If you're doing this in a calculator, I would still say do the positives together first, do the negatives together first, and then put them together. Does that make sense what I'm saying? Put the negatives together and then deal with them. Ooh, Sarah brings up a really good point. If we want to use the actual negative instead of subtraction, that button is right down here. It looks like a minus symbol, but it's actually the negative, and it's in parentheses. That's the negative. So if you were typing this in your calculator, you could just hit that button, and then you type 3.05 plus that button again, 2.05. And it should give you combined negative 5.1. Right? Yes? Maybe? I want to double check the keystrokes I just told you. And you'll notice if you compare that to the minus, they're different. The negative's slightly higher, slightly smaller. Like type both and compare them to each other, you'll see what I mean. You type both and compare them to each other. So now that also has a positive 6.1, and we had put this 0, but now it's unnecessary. Okay, we don't need that 0 now. 6.1 and a negative 5.1. Now, with my good guys, bad guys things, you can put them in battle with each other. Right? In your mind, if a 6.1 fights a 5.1, who wins? The 6.1. By how much? By 1. Not 1.1, just 1, right? So the positive wins by 1. Right? You don't have to put that little plus, but that's how my brain works. I see little numbers and they split off and there's good guys, bad guys, and then they fight each other, and at the end there's just what's left over, whoever won. Who's going to win this fight? Good guys, bad guys? Good guys, right? Because 8 is definitely bigger. But before we can combine it, what do we probably need to do, Toby?
Make the 1/2 2/4.
Make the 1/2 2/4, so it's common denominator. Now, when I do that, sorry, I almost forgot my 8. Tried to squeeze it in there. I will caution you. This one will work, but they won't always work after we've made that common denominator. Because take a situation where you have like 2 1/3 minus 1 2/3. I can't take 2/3 away from 1/3. So the 1/3 actually is going to have to borrow, one of those elementary words we used to use. And when it borrows, it leaves less whole. So really, long story short, improper fractions are the safest option. Okay, so I always advise, even if we think the subtraction can be done without improper fractions, if you make it improper, you know that it's going to work out okay. Go. What? No, I didn't want you. All right, we're not done. Sorry, I'm trying to move the screen and it's fighting me. So I'm going to improper fraction. If you didn't, that's okay, but let's check and see if you got the same thing. 1 1/4. Did we talk about the triangle method in here? Yeah, so 1 down to the 4 makes 4 because we multiply. Plus 1, 5/4, and make sure you keep that negative symbol. Plus 8 times 4, 8, 16, 32, 34/4. And in my brain, I kind of turn things around. And I said, well, I could do negative 5 plus 34, but I could also do 34 minus 5. Right? And in my brain, that's easier. What's 34 minus 5? 29. And our answer is 29/4, and you could leave it like that. But if you make it a mixed number, what? No. Really? I broke it. There we go. I really don't know what was just going on. 29/4, what is the whole number we can pull out of that? 4, 8, 12, 16, 20, 24, 28. Yeah, 7. 7 and... Come on. Just can't quite make it. 7 1/4. If you make it mixed, which you don't have to unless you're asked to make it mixed. Okay, unless I ask you, you can leave improper fractions as improper fractions. Do we need more time with E or F? Good guys with good guys. phrase a little bit more like things that will make people nervous sometimes. So trying to say like I can get this, unless you type it in the calculator and you're pretty confident. So here, who's gonna win, positive or negative? Positive. But then when I try to go do it and figure out what the difference is, I can't take 6 away from the 4. Right? So this is where things like this get annoying. My advice is just use a calculator. But if you don't have a calculator, remember this is where that borrowing is going to come in if you do it manually on paper. Is there anything else we could do? Any other way we could solve this? Oh. Yeah, 600. Yeah, we would just borrow, right? Or honestly, just use a calculator. Seriously, unless you're told you can't, just use a calculator. You know how to do this, right? You would borrow, you would set up the thing, the 4 becomes a 3, the 14, or the 4 becomes a 14, that whole thing. You know how to do that, but you don't need to if you have a calculator. Okay, that's the point I'm getting at. Now, fractions, though, are sometimes harder to type in the calculator and more annoying, and like I make mistakes when trying to type in fractions, right? We probably all do. So try to solve this one without the calculator. Let's put good guys with good guys. So what would my denominator want to be here? 6. So the first thing I'm just going to do is rewrite with the common denominator. That would double the top and bottom. Please make sure you're putting some work on your paper for this. I'm going to move my positive over so that it's near my other positive. So 3 1/6. But I'll still bring down my negative, don't worry. I just moved people around. They're still on the same battlefield. My 1/2, right? I should change that. Right, I should go ahead and make that common denominator. What's 1/2 if I make it into sixths? 3/6, right? You gotta have half of the 6. Yeah. Because 26 1/3. Yeah, but not yet. I just rewrote it. So now, like Nick is impatiently asking me to go ahead and get on with 26 2/6, 3 1/6. I get 29 3/6. Now, for the positives, grouping the positives together, then minus 12 3/6, still, or negative 12 3/6. Can I do the partials? Am I able to do 3/6 plus a negative 3/6? Oh yeah, because 3/6 is a half, and this negative is really a half, and yeah, those cancel each other out, right? They turn into 1, or turn into 0. 29 and a negative 12, 17. So our good guys here win by 17. If you want to get in the habit of circling your final answer, that's what I normally do. So for those of you asking, wait, is that the answer? Like, I often circle my final answer. We did not find the answer to E because I told you guys to just use a calculator. All right, any questions on those? I got to keep moving because I, for sure, absolutely have to cover absolute value before you get out of here. So again, on your homework, we're not going to do this because we don't have time. But if we look at movements like this, that's why we use plus the negative. We're adding a move in the backwards direction, right? I can't like take away steps I already took. Can't go back in time, but I can walk the opposite direction. So CPM will ask you to start making tight ropes that look like this. I'm just covering this stuff really fast, so you guys don't really need to write anything down right now. But how would we use negative 2 plus 3? How would we represent this? Here's the tricky part that people often miss. So give me your eyes up here, please. Everything starts at 0. So like when you open a bank account, you start at 0. You might immediately go into debt if you get a credit card, or you might immediately put money in, but we always start at 0. So to represent negative 2 plus 3, we would actually show the negative 2 shift. and show that we land here, and then show the 3 shift, and we end up at an answer of 1. So please beware that we start at 0. You wouldn't start at -2 and go from there. You show both shifts. You show a shift to the -2 and a shift to the +3. Any questions on that? I'm trying to go quick because I have something more important to cover. So 8 plus a -5, 8 up, 5 back.
So you don't have a 5, right?
Yep, you would end up at 3. All right, so this is on your paper, and this is what we really have to talk about. So I just need everybody to take a moment, without talking, just read what your paper says about absolute value. Oh, I didn't put the whole definition, did I? There's a reason, because you guys don't like long definitions.
Absolute value.
Yeah, and it has a semicolon, right? So you see that big long definition up there?
Yep. Yeah.
You don't want that whole thing.
Nope, we don't.
Here's the definition of absolute value. Oh, that's a absolute value. You know what? We're just going to do a new screen.
Nope. So we read it the
Gets abbreviated like this, but you have absolute value on your blue sheet. I would like you to write on your blue sheet, actually, so you can reference it on your homework. Absolute value is final distance from 0.
Did you memorize this? Or is it stuff like
Oh man, I've been teaching long enough. There are certain things,
you look young?
and you'll know it by the end of the year. You'll like people will be like absolute value. Oh yeah. Which the other kind of trick memory thing people will tell you about absolute value.
That's like the ending.
It's always going to come out positive.
Yeah.
You cannot go a negative distance. That would be like going back in time. Right? If I walk 6 feet this way, and I walk 6 feet this way, well, the second way is more fun, but that's not a negative distance. I've now gone 12 feet. Right? Like the distance covered is always positive. Negative is direction. Cody?
Like for this one, on one of these problems that's on the blue paper, it says the answer to the question would be -35.3, the absolute value is 25.3 because
Not that one. Are you talking about one of the ones right below where it says absolute value? So one of these?
Yeah, on the paper at 245.
Yeah, so if Cecil or whoever we're talking about goes and makes the moves of 20 in the negative direction and another move in the negative direction of 5.3, this will become combined negative 25.3 is the total moves he did. But to get rid of the bars, I haven't hung it up yet because it will hang up after today, now that we've talked about it. We have to get it out of jail, quote unquote. Some teachers like that trick of like, to get out of jail, you have to become positive. I don't like that, but your final answer is positive, and you might want to write a plus or a positive or something. The distance he covered was 25.3.
I just noticed that on like C and D of both of those two,
Yeah.
that there is a negative sign and then a bar.
Out in front.
Yes.
All right, I'm not going to worry about finding that poster until I'll do it once you guys leave. So, let's get to that one, right? I like what you're thinking, and you did notice, like, wait a minute, that's outside of the bars. It's still going to be there after the bars disappear. All right, so hold up. With B real quick, are the moves same direction or different direction? 45 and 7.7, they both go the positive direction. How far did he go when we combined those moves?
He went forward.
Yeah, 52.7. Now, if we still keep the bars, because all we did was add, do I have to do anything to get rid of the bars? No, it's already positive. So to get rid of the bars, it's just 52.7. I don't know what this stuff is. Yes.
When we're done with this semester, can I throw away all this stuff?
We will give you folders and filing cabinets. I'm actually trying, that's partly why I cleaned up my desk. I need to get more folders. We ask you to keep most stuff until student-led conferences. So that's a good question from Nick. You're starting to get a lot of papers accumulated. we will give you hanging folders in filing cabinets, and probably where your advisor room is, or foundations room. Keep the stuff for now, right? You don't know what you're going to need for student-led conferences. Keep it for now.
I think she can.
So, Nikki, what do you predict we're going to do here since that negative's on the outside? What if these were parentheses? That's absolutely right. So if you didn't hear Nikki, she said, well, if they were parentheses, you would just do the inside first and then apply the negative. That's absolutely what we do here. So inside the parentheses, or inside the absolute value, 8 plus 81, what's that? 89. The bars are still there and the negative is still there. To come out of the bars, the 89 turns positive, but the negative is still there, and it's negative 89. Try D real quick.
Hold up.
He started at 0. He went 3 the negative direction.
I am way confused.
Okay, why, Toby?
Because for C, absolute value is just the distance from 0, so you said that can't be negative.
You are absolutely right. This is outside, though. Absolute value takes whatever's inside and says, what is that distance from 0? So that turns into this 89 and this 89. But that negative was out front, and it's still out front, but now it's right up against the number. Does that make sense, Toby? So it's like the order of operations. Absolute value, because this might help. Like, I like that you pointed out that confusion. Absolute value works in the same place as parentheses. So if you're thinking down the order of operations, it's the same as parentheses. So Toby, here we have parentheses and absolute value. Can we do anything inside that parentheses? Is there any math to do? Addition, subtraction, multiplication, division? No, there's nothing to do. So this becomes, this is still on your paper, so we should be writing this down. Right, the parentheses go away. It's still a negative 3 inside the absolute value. What happens to this negative 3 to get out of the absolute value? It becomes positive, but what happens to this? It stays there. And it's negative 3. Questions? So really, that's the opposite of 3, right? Or negative 3. Can I say that that's minus 3? No, because there's nothing to subtract from, right? We don't call that minus 3 when there's nothing to subtract from. Bella? It's magical? If that's the thing, right? It's the magic positivity creator. So I will, and for nothing else aside from, like, even if at a minimum I can get you to just laugh at me, I'll take that. If you're in a really bad attitude, having a really bad day or something, I might just be like, hey, absolute value yourself. Come on. Like, you don't just roll your eyes and be like, come on, Hudson has to put math into everything. Get positive, right? Like, take your negative attitude, get out of that absolute value, get positive. And Estes is like, what a nerd. I can read Estes' mind right now thinking about how nerdy I am.
What? Build an absolute value
To
chamber.
put people through,
A physical chamber.
right?
Get your absolute value.
So, here's the last thing we're going to talk about today, because we only have like 1 minute left, and you don't even have to write anything down. If Cecil, or whoever, goes 5 feet one way, and 5 feet back the other way, where do I end? 0. What do you mean? Where I started, right? So it depends where I started. I didn't say I started at 0, right? I just said if I go 5 feet this way and 5 feet that way. So remember that opposite moves cancel each other out, which I don't really like the word cancel because it makes it seem like nothing happened. Stuff happened. But you get back to where you start, and it depends on where you start. This, eventually we'll write this down, and I'll need you to know this this vocab word. It's called additive inverses. A 5 and a negative 5, additive inverses. A 7 and a negative 7, because they make 0. That is all I got for you. Remember, we're going to go through the wall. We magically go through the wall, so you can just chill here for a minute.
Oh, wait.
This works all because that class knows the column, and they just leave the pod. And this class can go through the wall.
That'd be great if Tony was teaching about distillation.
Oh, yeah, sure. Is it hard? I didn't know if you were just super into snakes. No, that's not going to work.
Like everybody, all my other friends are Hufflepuffs, and I'm just like the one.
I don't. The last time I took that quiz was a long time ago, so I wonder if I would have. I forget what.